Okay, so as you can see, we're going to be using the law of sines to solve oblique triangles. Now, the first question is going to be, what is an oblique triangle? And what you need to realize is that an oblique triangle is a triangle that is not a right triangle. Okay, guys, you have to understand that in the perfect world, not everything is a right triangle. So mathematicians went out and they tried to figure out how we can solve for parts of a triangle if the triangle is not perfect and right. So they developed the law of sines. Now, as it says, oblique triangle is a non-right triangle. When you're doing these problems, you need to make sure that you're labeling your triangle correctly. If you don't label your triangle correctly, you're not going to get the right answers. So things you need to know that your angles are always capital letters. So when we label our triangle, we label them in capital letters. It doesn't always have to be A, B, and C, but they're always capitals. Then sides are always lowercase letters, and then opposite angles and sides have the same letter. So what you will see here is an example of that. Okay, so here is a triangle where our angles are capital A, B, and C, and then our triangle, our sides are lowercase, little a, little b, little c. And then you'll also notice that big A is opposite of little a. And then big B is opposite of little b, and big C is opposite of little c. Make sure you're drawing your triangle correctly. Now, also in the directions, you'll be asked to solve the triangle. That means that you have to find all the missing parts. So all the missing sides, all the missing angles. Okay. So now, this is the law of sines. If you notice, it's really just a ratio, okay? So we have sine of big A over little a, sine of big B over little b, and sine of big C over little c. Now, guys, you're not going to use all three of these at the same time. You're going to use two of them. So if you're given A's and C's, then you're going to use this one and this one. Okay, if you're given B's and C's, then you would use this one and this one. So it's all dependent upon what you're given. Now, you can only use the law of sines when you're given angle, side angle, or angle, angle, side. So basically, you have to be given two angles right now in order to use the law of sines. So where are we going? This is where we're going, guys. Okay, so if you look at this, what we're going to cover today is angle, side angle right here, and then angle, angle, side. We're going to cover these two scenarios today. Then at the end of the week and into next week, we're going to spend a ton of time on this particular one. This is what we call the ambiguous case of the law of sines. It is a little more difficult. And then we'll move into the law of cosines, which are the bottom two triangles. So today we're going to focus just on these two problems, angle, side angle, and angle, angle, side. Okay? So here is our very first example. Solve the triangle given that angle A is 36 degrees, angle B is 42 degrees, and little b is 15. Now, I want you to get in the habit of drawing a picture, because once we do a lot of these problems, it's really hard to decipher what to do when, so drawing a picture will help you with that. Remember, label your angles as capitals, so A, B, and C, and label your sides as lowercase. So if this is big A, we're going to put little a opposite, big B, little b, big C, little c. Now your A doesn't necessarily have to go down here. You could put your A over here, okay? Or anywhere for that matter. Just make sure that your little side is across from the big angle, okay? Then we're going to label the parts. So angle A is 36 degrees, angle B is 42 degrees, okay? And little b is 15. So you are always going to be given the law of sines on a formula sheet, which is helpful. So we're going to know that the formula says sine of A over A equals sine of B over B, which equals sine of C over B. And what you'll notice is that you have a capital A and a lowercase a, or a capital B and a lowercase b, or a capital C and a lowercase c, okay? They're all based on pairs. So what you're going to hear me say over and over again is, do you have two A's, two B's, or two C's? And that's how this formula is going to work, okay? Now, looking at this triangle, our directions are to solve the triangle. If we're to solve the triangle, that means find all the missing parts. So we are missing big C, we are missing little a, and then we are also missing little c. Now, you need to dig deep and go back to geometry and remember, what do all three angles add up to? And if you thought to yourself they add up to 180 degrees, then you're right. So I should be able to find angle C, okay, by taking 180 degrees and subtracting 42 and 36, because that's going to be what's left over, okay? So when we do that, we get 102 degrees. So angle C is 102 degrees. So you always need to find that missing angle first, okay? Now we're going to move on to the missing sides, little a, little c. Okay, that's where we're going to use our law of sines. So back to the pairs. Ask yourself, do you see two A's, two B's, or two C's? Now, what that means to us is you'll look, angle A is 36 degrees, but I don't have side A, so I don't have two A's. But angle B is 42 degrees, and I know that side B is 15. This is the pair that we're going to use for the whole rest of this problem. So you're going to write this. We're going to use this part of the equation. So we are going to say sine of B, we're actually going to write in what B is. So sine of 42 degrees over little b, which is 15, okay? Equals, now we need to decide whether we're going to solve for little a or little c. It doesn't matter which order you go in. I typically go alphabetically. So if I'm going to solve for little a, for instance, then I'm going to use this formula. So I'm going to say sine of big A, which is 36 degrees, over little a. Okay, now once you have a fraction equal to a fraction, you guys are rock stars at this. So after you have a fraction equal to a fraction, remember we're going to cross multiply. So we're going to cross multiply this way, and we're going to have a sine 42 equals, and then we're going to go this way and get 15 sine 36. Notice I have not picked up a calculator yet. Now, last step is to get a by itself. And if we're going to get a by itself, we're going to divide by sine 42. Okay, so when we do that, we know that little a equals 15 sine 36 over sine 42. Now, from there, you're going to pick up your graphing calculator because you're going to have a graphing calculator in this unit, and you're actually going to type this in. So, on your calculator, you're going to do, okay, so you're going to have a fraction, so alpha y equals, okay, and you're going to have 15, and then sine, and then remember it's 36 over sine 42. Okay, now many of you haven't used your calculator since we cleared the memory, and if you typed this in your calculator right now and did not get 13.18, then you're in the wrong mode. Because our angles are in degrees, we need to make sure that our calculator is in degree mode. So when you go down, most of yours are flashing in radian right now. You're going to need to arrow over to degree and press enter. Okay, and then when you second quit, now you're going to end up with the right answer every time. So what we know is that little a is 13.18. Okay, now this b that we use, this original b, sine b over b, which is this, is what we're going to use to go back and find little c as well. So here we go. So we're going to take all of this, and we're going to do this again, okay? So same thing again, but the difference is we're still going to use sine b over b, so we're going to start with the same fraction, so sine 42 over 15, but this time we're looking for c, so we're going to use sine c. So we're going to do sine, and then big C is 102 degrees, so we're going to do sine of 102 degrees divided by little c, which we're solving for. Okay, now we're going to do the same thing and cross multiply. So we're going to get c sine 42 equals 15 sine 102. Okay, and then get c by itself, divide by sine 42, and c equals 15 sine 102 divided by sine 42, and we're going to type that in our calculator. So 15 sine 102, so alpha y equals 15 sine 102, okay, divided by sine 42. Okay, so when you're done, you're going to press enter, and it's going to be 21.93, and that is side C. Okay, so that's our very first example for the law of sines. I'm going to upload another video to give you another example so you can see how this works again, and then we'll go from there. All right, thanks.